So my name is Nathan. I'm here with my team, Leon, Duncan, Uma, and Anne. This is Project Lisa, and we are building software to help city planners predict the impact of bicycle infrastructure investments. So unlike a lot of the other scope teams you've seen here today, our project is the funding and the technical expertise is split between different organizations. So we receive funding from the Santos Family Foundation. They provide funding for lots of projects that focus on improving vehicle safety, including those that reduce injuries to vehicle occupants, pedestrians, and bicyclists. But we receive technical expertise from, for example, the Volpe Center, US Department of Transportation, where they are experienced working for our nation's transportation challenges. They have a broad variety of technical expertise that range from road infrastructure to air traffic control and even cargo shipping. And finally, we have DDOT, or the District Department of Transportation. We also receive technical expertise from them. They are responsible for improving and maintaining the transportation infrastructure in Washington, D.C., enhancing the quality of life of all the district's residents. And so these organizations came together to create our project, where we're working on a shared vision to improve road safety and accessibility for bicyclists. And how this is going to be done is by building bicycle infrastructure. So this is an example of what is called a cycle track, which is a completely protected bike lane. This was built by DDOT right in front of the capital of DC. And this is the strategy we're using to make bicycling more safe and accessible. That being said, building bicycle infrastructure is expensive. And so because cities run on limited budgets, it's important that city planners build the right infrastructure in the right locations. And so that's where we come in. We are building software to help those city planners predict the impact of bicycle infrastructure investments. And this is split between two different types of software. One is a bicycle behavior model, which allows us to simulate realistic bicycle behavior. This is built using machine learning, analyzing the behavior of real bicyclists by tracking their GPS data. And then this is going to be used in a virtual city, which is the sandboxed, computerized environment that the city planners can use to test and experiment and understand the potential impact of bicycle infrastructure investments. So the virtual city, which we haven't built yet, but is going to be built, looks a little bit something like this, where, I want to try this. Haha. So we have a bicycle that starts in the upper left corner, and this bicyclist wants to travel down to the bottom right corner. And there's a couple of possible paths this bicyclist could take to get to that destination. And so they could choose to travel through the bike lanes, staying safer for a longer period of time, or they could take a shorter path, sharing the road with other motor vehicles. And so there's two possible paths, but to complicate matters a little bit further, let's say that this particular intersection is known to be particularly dangerous. And so it's the job of the city planner to build more bicycle infrastructure so that this bicyclist can stay safe. One potential possibility would be to build a bike lane traveling diagonally along the shorter path, also including paint through the intersection to make that intersection much less dangerous. Another possibility would be to keep the intersection and not address it explicitly, but to provide a longer but safer path to incentivize bicyclists to travel along safer roads. And so now that we have potential infrastructure plans, we actually want to know whether or not which one will work. And so that's where the bicyclist behavior model comes into play. This is the piece that lets us simulate virtual bicyclists traveling throughout this virtual city. And this is built by analyzing the behavior of lots of real bicyclists. So we get GPS data from lots of different companies of bicyclists traveling on their various trips. We can analyze that with machine learning and build a bicyclist behavior model, which will help us understand how bicyclists are likely to travel through a city. And so applied at this intersection, it wouldn't make a lot of sense for bicyclists to turn left or turn right because those don't lead you towards your destination. But traveling along the bike lane or traveling through the shorter path are still possibilities. And so we can also take this bicycle behavior model and analyze paths that the bicyclists could take from a start to an end, not just at an intersection. And so that's where we spent the majority of our time this semester building software to create this bicycle behavior model. And so although scope ends today for a lot of us, our project will continue on. So because we get funding through this foundation, sorry, you guys got a weird error message, it's fine though, where it's gonna automatically turn off in 52 seconds. So if someone wants to fix that while I'm continue talking, that'd be great. It's counting down, 41, 40, 39. But regardless, our project will continue on. It's being published as an open source project on the internet, where other traffic engineers can build upon our work. Oh, we have a different slide. Oh, now we're both controlling it. It's also unclear if this is a thing with the mouse or this monitor itself, so I'll just keep going. Also, all of our results are being sort of aggregated into a paper, which we are submitting to the Transportation Research Board. Oh, it's off. So, in addition to that, depending on how sources of funding come through, Volpe, our collaborators, want to continue making progress towards building the virtual city. And then also the District Department of Transportation, even though we didn't talk about much of this during the presentation, infrastructure, high fidelity infrastructure data makes efforts like this virtual city possible. And so they are gonna continue developing one of their particular systems for storing and referencing all different types of road infrastructure. And then finally, just wanted to thank everyone. There's a lot of people to thank, but particularly the Santos Family Foundation for providing funding to our project. Our liaisons, Stephanie Dock, Mike Goodnow, James Graham, Stephanie Brody at the District Department of Transportation, Volpe Center, U.S. Department of Transportation, Alex Epstein, and Jonah Chiarenza. And then also the SCOPE program, our faculty advisor, Lynn Stein, and our subject matter experts, Paul Rubelo, Jason Woodard, and Alan Downey. And then I forgot to say Paul Santos and Stu in particular. Thank you so much.